Hi, and welcome to Calculus 30 with Miss Verity. Today we're starting our brand new unit, which is differentiation, and starting with section 4.1. So, slope of a line. The slope of a line is a measure of its steepness and can be determined by the ratio of the rise, which is your change in your y, to the run, which is your change in your x, as you travel between any 2 points on the line. So, steep lines have a large slope, while lines that are almost horizontal have a small slope. So a horizontal line has a slope of 0, and lines with a positive slope rise as you move from left to right, and negative slopes fall from left to right. So find the slope of the line passing through the points 3, -7, and -24, -28. This is where we use our slope formula. M is equal to y2 minus y1 over x2 minus x1. Hopefully we're familiar with that from grade 10, but if you're not, we've got an x1 and a y1, x2 and a y2. Remember, it doesn't matter which order you put your ones and your twos, as long as all of this point is a 1 or a 2 and all of this point is a 1 or a 2. So plugging into our slope formula, y2 -28 minus y1 over x2 minus x1. So that will give us -21 over -27, and that reduces to be +7 over 9. Okay, so we're going to write the equation of the line in the following form. So there's our slope, and we've got our 2 points that we could use. So slope-intercept form is y equals mx plus b. So we need to figure out what our b is. So we've got y equals 7 over 9 x plus b. Picking your favorite point from up here. I'm going to pick this point just because it has a multiple, 3 is a multiple of 9. So -7 equals 7 over 9 times 3 plus b. This reduces to be 1 and a 3. So -7 equals 7 over 3 plus b. We're going to subtract 7/3 from both sides. So -21 over 3 minus 7 over 3 equals b. So -28 over 3 is equal to our b. So our overall equation then would be y equals 7 over 9 x minus 28 over 3. So point slope form. This one is our y minus y1 equals mx minus x1. When it comes to calculus, this is actually my favorite form. It's the easiest. All you need is your slope, which we have, and your favorite point, which could be this one or this one. It really doesn't matter. And we just plug those in. So y minus our y coordinate of our point. If I'm going to pick this point, it's going to be 7. So plus 7 equals 7 over 9 x minus 3. And that's how we would leave it. We don't have to solve for anything. Standard form is ay plus bx is equal to c. In this, I have to remember off the top of my head. I think it's our x coordinate. No, it's our a. Our a has to be positive. General form is basically the same. Ay plus bx, it's just plus c. It's set equal to 0. And this one, your general form, your a has to be a positive whole number. You can't have fractions in your general form. I'm not going to do the work for those. Basically, take one of these equations that you would have found and either isolate your constant term or get it set equal to 0. Again, with the set in general form, you can't have fractions and your y has to be positive. So write the equation of the line that has a slope of 2/3 and passes through the following point. Pick your favorite form. For me, this would be my slope point form because we are given a slope and we are given a point. So why do any extra busy work if we don't need to?
So y minus our y coordinate, so plus 4 equals our slope 2/3 minus our x coordinate. So write the equation of the line in slope-intercept form. So y equals mx plus b. That is perpendicular to the following line and passes through a point. So when a slope is perpendicular, it is the negative reciprocal. So our slope is negative 1/2. And we've got a point. So plugging our point into our y and our x so that we can solve for b. So negative 5 equals negative 1/2 times 1 plus b. So negative 5 equals negative 1/2 plus b, add 1/2 to both sides, and that's going to be negative 4.5, which we don't use decimals. Negative 4.5. So negative 9 over 2 equals b. This, remember, you can multiply and then add your top one. Ignoring the negative, the whole number is negative. So our equation is y equals negative, negative 1/2 x minus 9 over 2. Next, separate the equation of the line in slope point form. So y minus y1 equals mx minus x1. That passes through the following 2 points. Basically, use your slope formula, m equals y2 minus y1 over x2 minus x1, and then pick your favorite point after you found your slope and plug those in for your coordinates. So write the equation of the line in general form, that is tangent to the circle. X squared plus y squared equals 100 at the given points. So, if we have a circle, let's draw it up here. Beautiful. It's more of an oval, but we'll take it. In this formula, what you don't know about circles is the square root of this is equal to the radius. So our radius is 10. So that means this point right here on our circle is 10, 0. This point up here on our circle is 0, 10. This point on our circle is negative 10, 0. And this one would be 0, negative 10. So, we want the tangent line. So tangent, remember, is either, there's a couple ways to think of it. Sine over cos. We also know it's y over x. Tangent lines Also, they have reciprocal slopes because they make perpendicular lines. So what does that look like? If we want the tangent line at 10, 0, tangent lines on functions are lines that touch at exactly one spot. Obviously, that needs to be moved. I don't know. Oh, I can do. Okay, so there is our tangent line. The the slope of that line is going to be undefined because it is a vertical line. They do not have any slopes. Or you could also say you could say that, or you could say does not